All right, ladies and gentlemen, let's get things rolling with part 3 of this Lesson 25 series about indexing. And in this lesson, in this part of the lesson, rather, we're going to be talking about the syntax involved in using this indexes in the real world. And we're going to also dive into some good examples of how you can use indexing inside of our Toad for MySQL. So now, having said that, we can get into real examples. So finally, we're landing on the syntax of how to create an index. There was a lot of talk about, obviously, how to create and use the indexes, but we haven't talked about the syntax. So if you were to create an index on the amount column in our transactions table, this is what you would type in. You would say create index, and you would give it a name. Okay, typically, the name of an index is the name of the column followed by 2 underscores, followed by the abbreviation of whatever type of index it is. Okay, so if it was a foreign key, it would be FK. If it was a primary key, it would be, well, whatever, I think PRI is the abbreviation for primary key, or maybe just PK, I guess. No, sorry, PK is definitely the abbreviation for primary key. In this case, it's just a plain old index, so the abbreviation here that we use is IDX, okay? It's not mandatory that you type this in this fashion, but that's just a convention. That's just a way that us, database guys tend to use or name our indexes. So, create index, name of the index on the table that you're doing it on, and then you specify the actual column that you're putting the index on. Okay, fairly straightforward. So the generic syntax for that is like this. So you can say create. And then you can choose, if you want to, you can choose the unique or the full text type. So what you'll notice here is the primary key type is not in here. So if I go back, you can see I had 4 types: primary key, unique, index, full text. Primary key is not in here because, like I said, the relational database management system will create it for you. It creates the primary key. You don't need to worry about it. So you can choose between a unique index, a full text index, or you can just not put in either of these and just say index, and that will create like the generic phone book type index that we were talking about above. Okay? And then, like I said, index name on, table name, and column name. So that is the syntax around it. Let's take a look at that in action now. So let me flip over to my Toad. And let's take a look at my transactions table. So right now, if I were to, I have probably over 5 million records now that I put into my transactions table. So if I say select star from transactions, and I say where amount is equal to 500, okay? And I run this query. I hit F5 to run it, and it is currently running, and in the bottom sort of, where'd it go? In the bottom area here, you see that it took 4 seconds to run that query. And 4 seconds isn't bad, but it's a little bit slow on 5 million rows. Okay. First, let me prove that I have 5 million rows. Let me go back and just say select star from transactions and run that. And let me move this up because that'll be better. Let me run this. And it's still running. So if you go down again, sorry, I'm scrolling around all the time. You go down here, you see that the duration, it just keeps ticking away. It just keeps ticking away and ticking away. And like I said, I think it'll go to about 30 seconds or so before it actually finds all the data inside of the transactions table. Creating an index on the amount column alone is not going to help for this type of query, because the type of query I just did was select star from transactions. So in that case, it would have to do an index. I have to create an index on every single column, and we know that that's a bad idea for trying to speed up a query. So with a query like select star from transactions, you're never going to be able to speed that up. You need to think of a different way, a different type of way to query the table, because select star from transactions is just not a good idea. So you saw that it took 46, almost 47 seconds to query just over 5 million rows. So, okay, that's just to prove to you that we have a lot of rows in this table. So now let's go back and run our whole query here, which is select star from transactions where amount equals 500. And it should take, again, somewhere around 4 seconds to run. And sure enough, so 4.5. So it's going to vary every single time you run it. It's not going to be exactly the same. It varies, okay? And there's a whole bunch of reasons why it could vary. But just take my word for it, it'll vary. If I run it again, let's see, it'll go how many seconds this time? 4.2. So it's always somewhere around the 4.5 second mark, okay? So now that's when you do not have an index on the amount column. So now let's create one. Let's say create index, and let's call it amount, 2 underscores, IDX, so that's the name of the index, on transactions table, and then we need to tell it what field on the transactions table you want to introduce the index on, okay? And I'm going to select this, and I'm going to run it. Now, when I run this is actually going to take a little while, because think about it. It's creating an index, so it needs to go through every single column, every single row for the amount column, which is going to be over 5 million rows. And it needs to take a look at the actual amount for all of those rows, and it needs to sort it. Okay, so if you guys have ever, had any sort of experience with sorting, you know that it takes a little while to sort stuff. But there you go, it's done. It had created the index in about 28 seconds it took to go through, sort everything out, create this table that we cannot see that maps the amounts to the transaction IDs. All right, so now I'm going to show you something. I'm going to go back, and I'm not exactly sure what's going to happen when I run this query, because I think there's something going to be at play here that I haven't mentioned, but we'll see if it's quicker than 4 to 4.5 seconds. Let's run that and see. Okay, so for sure it's quicker, so that's good. I wasn't sure if it was going to be dramatically quicker, but you can see that it definitely is dramatically quicker. So it took less than 1 second, so it took 0.421 seconds to run that query. And I can hit it again. This time it's 0.123, so even faster. And again, 0.160, again, 0.061. So it's getting quicker and quicker every time I run it. So that just goes to show the dramatic improvement on indexes once you introduce an index. Now, one thing that it doesn't really improve a whole lot when you're doing an equality type operation, so when you're saying where amount equals something, or where a column equals something, and that column is actually an indexed column, doing an equality thing is pretty quick. But if I change this to be something like a range, we call this a range selector, so something like amount greater than 500, it's going to take a little bit more time. So if I run this query with the index, let's see how long it takes. So we're going up 6 seconds, 7, 8, 9. So you see, even with an index with 5 million columns, even with that column indexed, it still takes a long time to query this, for this type of data, for this greater than 500 type of query. Okay, there you go. So almost 25 seconds it took to run that query. Now, the thing that's at play here is something that is a little bit tricky, because what happens is inside of the index is storing the amount as well as the transaction ID. So let me go back to my presentation, which is here. Let me go back to that slide where I was showing you. Yes. So the when it stores the actual index itself, when it does the index, it's just storing the amount as well as the transaction ID. Okay, those are the two fields that it's storing. But when we ran our query for the range selection query, so this query up here, we are saying select star from transactions. So because the index only stored transaction ID and amount, because we're asking for select star from, it needs to do more work to actually get the rest of the fields. Because now, since I say select star, it's not only looking for amount and transaction ID, which is stored in the index, it's also looking for transaction date, transaction type, bank account ID. Okay, you can ignore this column. This was part of the last Q&A webinar I did. The column snuck in there. I should probably just remove that. Let me do that now. Okay, so now I've removed that extra column there that wasn't supposed to be there, and I reran the select star from transactions where amount is greater than 500, and this time it ran, in just over 31 seconds. So you see that the speed can vary quite wildly, but the point I'm getting at is that you when you perform the select star, you're giving it more work because it does not have the appropriate columns inside of the index to reference, so it needs to do all these individual, whenever it finds a match, it needs to go and grab all the related data for that table, or rather for that row. So if you wanted to actually create a query that was even faster, if you did not need to use a transaction date, transaction type, or bank account ID, if all you needed was the amount and the transaction ID, then you could specify that in your select statement. So it actually matters what fields you put in your select statement. So you can say select transaction ID, comma, amount from transactions, where amount is greater than 500. So as you can see, these are the two columns that actually exist inside of my index that I've created. Okay, and since they are already there in that index that I created, it doesn't have to take as much time to go through and look up all the other columns. So this should theoretically be faster than 25 seconds. So let me run this and see what we get ourselves into. So now it is going through, and it is, you see, it's the amount of data being returned is far less, and sure enough, the duration of this query is also far less. So this one only took just under 10 seconds as opposed to 25 to 30 seconds to get the appropriate data back. Okay, and again, to illustrate my point, hopefully this all goes well. I actually haven't tested this out, but if I typed in transaction date as a third column, I would expect this to actually go up a fair amount from 10 seconds. You know, I would think that this would force it to do lookups for every single row, and it would be a lot slower than 10 seconds. So I'm thinking it would be more like 20 seconds, but who knows? Let me run this and see what happens. So just by adding one extra column as a test, let's see how much further it goes than 9.8 seconds because it has to do those extra lookups. So we're on the 12, 13 seconds, 14, 15, 16. So there you go. We've already hit more than 16 seconds. We've hit 20 seconds now. So just by adding one extra column, there you go. So now it's done. It's taken 21 seconds as opposed to under 10. So you can see how dramatically your queries can change depending on what columns you're selecting. That is the point I wanted to drive home here. So there's more than just indexing to make your queries faster. It's more than just knowing that, okay, I need to index the amount column and then all of my queries will be faster. Well, actually, no, that's not the case. You need to be smart about what you're selecting as well as what you're indexing. So there you go. Hopefully that's a big help to you. Hopefully you really enjoyed this really in-depth talk on indexes. Like I said, there's lots of information available out there on the internet with respect to indexes and with respect to all the intricacies. I can certainly talk about indexes for a long time. But instead of doing that, like I said, I just wanted to give you a nice overview of indexes and some tips and tricks with how they work and whatnot, with some actual real world explanation and some real world examples. Okay, so hopefully that helps you very much, and I look forward to seeing you in the next lesson. Bye for now.